Okay, so we are going to finish up section 1.5 notes by talking about average rate of change. Okay. Recall slope. To find the slope, if you're given 2 points, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's what should go there. My stylus is not going to fit all that in there, so you go ahead and put that there in your notes. And so that the slope is, remember, it's a rate, and a rate compares two quantities. And so here we're looking at the change in y over the change in x. Now mathematically, we can look at this as delta y over delta x, which that's the Greek letter delta. And delta stands for change in. All right, so it's a change in y over the change in x. So that's the mathematical notation of the Greek symbol delta, okay, which you'll get to know a lot better in Calc 1. So the average rate of change between any 2 points, and because we're referring to functions, we'll say x sub 1, f of x sub 1, and x sub 2, f of x sub 2, is the slope of the line through those 2 points. And the line through those 2 points, we call that the secant line. Okay. And so to find the average rate of change, so the formula for the average rate of change, since it's the slope of the secant line, and I'm going to use ROC for rate of change. All right, so it is f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. And I hope you see that this is the same formula for slope. It's just now, since we're talking about functions, we know for slope, for functions, y is equal to f of x. So it's the change in f over the change in x, okay? But it's the slope formula. And visually, graphically, if I have enough room here, let's see, so if I have, okay, so let's say I have some graph of some function here, and I'm going to pick just any 2 points on, which 2 points do I want to pick? I'm not going to pick any 2 points I want. Let's say I'll pick, alright, so let's say I'll pick this point and this point. They're usually points close together, and you'll understand that better when you move on to applied calc. This is sort of an intro to this, but the average rate of change, so if you draw a line through those 2 points, this is your secant line, and the average rate of change is just the slope of that line. It's the slope of your secant line, okay? All right, so now let's look at an example, okay? Example 10. So find the average rate of change of f of x equals negative 2x plus 15 from x sub 1 equals 0 to x sub 3 equals, x sub 2 equals 3, okay? And so again, for average rate of change, we know it equals f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. So in this example, it would be f of x sub 2 is 3, so f of 3 minus x sub 1 is 0, all over 3 minus 0. Similar to whenever you have an expression where you have to evaluate different inputs, so f of 3, f of 0, f of x plus h, f of 2, whenever you have to evaluate different inputs, you should do a piece by piece, just like we did it with the difference quotient. And so on the side here, we're going to evaluate f of 3. And again, this is a function. 3 is my input. So wherever I see an x, because x is my input in the original function, so wherever I see an x, I'm plugging in 3. So this is going to be negative 2 times 3 plus 15. That's negative 6 plus 15. And so f of 3 then is 9. Then f of 0. Now 0 is my input. And so wherever I see an x, I plug in 0. So that's negative 2 times 0 plus 15. And so f of 0 is 15. All right. So now we go back and plug in. F of 3 is 9. So we have 9 minus f of 0 is 15 over 3. So that's negative 6 over 3. And that's negative 2. And so that's our average rate of change for that function. Okay. All right, this last one, and my suggestion would be to pause the video and try to solve it on your own first, and then come back to see if your answer is correct and if you're thinking about this correctly. Okay. All right, so now that you're back, let's see if your answer is correct. Welcome back. Okay, so we have f of x equals x cubed minus 3x, and we need to find the average rate of change from negative 2 to negative 1. Okay, so that's f of x sub 2. Actually, I'm going to skip that because you guys already did this. So that's f of negative 1 minus f of negative 2 all over negative 1 minus a negative 2. Be very careful with these negative signs because they can easily trip you up. Okay. And so that's just simplifying this a little bit. That's f of negative 1 minus f of negative 2 all over negative 1 minus a negative 2. That's going to be plus 2, so that's just over 1, a positive 1. Okay, but we still need to evaluate f of negative 1 and f of negative 2. Okay. All right, so we go over to the left-hand side of our notes. F of negative 1. Negative 1 is my input, so I would always use parentheses. You can use parentheses anytime, but especially when you have negative values because it's very easy to miss a negative. All right, so that's negative 1 cubed minus 3 times negative 1, so that's negative 1 plus 3, so that's a positive 2. And then f of negative 2, I'm running out of space here, is negative 2 cubed minus 3 times negative 2. Since you did this already, that should simplify to, that's going to give us a negative 8 plus 6, so that's a negative 2. All right, so now we can come back over and input our values. So f of negative 1 is 2, so we have 2 minus f of negative 2 is a negative 2 all over 1. So it's very easy in this example especially to get 0 as your answer. So if you got 0, that means you missed your negative, so be very careful. All right, because that's 2 minus a negative 2, so that's going to be 2 plus 2. So we're going to get 4 over 1 or just 4. Okay. Now I think I said I wanted to do a last example of an even or odd function or neither. So let's look at actually that last example. I'm going to take that function. And I'll say this, don't assume, because in class we looked at the cubic function, right? And we saw that the cubic function was an odd function, right? Don't assume that whenever you see a cubic function, it's going to automatically be odd, especially if there are other terms after it. Because those other terms after, remember, for both situations, hopefully, I don't know if you're hearing the ice cream truck outside my house, but anyways, for both situations, you have to input negative x into your function. So to determine whether a function is even, odd, or neither, plug in negative x into your function, and if you get back the original function, it is even. If you get back negative, the original function is odd, and then it's neither if you don't get either choices back. So let's look and see what's going to happen here. So step 1 then, and we're almost done with this video, is to plug in negative x. And so that's negative x cubed minus 3 times negative x. And that's going to be negative x cubed, once you simplify, plus 3x. Now here's the thing. And I didn't get a chance to mention in the class because with the example we had, I didn't need to. But here's what you have to do. After you plug in negative x, and once you simplify, if it's not the original equation, so original function, that's our original function. If it's not the original function, then you need to go a step further, sorry. And so step 2 is to factor out a negative. Okay. And so we're going to take negative x cubed plus 3x. And if we factor out a negative, actually we could say a negative 1. It's really a 1 there. We just don't write it, but it's always a 1 being multiplied by any number. We just don't write it. So if we factor out a negative 1, then we'll get x cubed, right, minus 3x. Okay. And we'll get x cubed minus 3x, and then you can multiply back through the check. And so here's the thing. If what's in your parentheses is your original function, then that means it's odd. But it may not be clear right here that it's an odd function. So you have to take it step 2, I'm sorry. You have to take it a step further by factoring out a negative 1 from each term. Okay? And so since this gives us back, so that's really because, remember, the definition of an odd function is if you plug in negative x, you get back negative f of x, and that's what we're doing, right? We're getting back negative f of x. So that means this is an odd function. Go back over this video as many times as you need, and if you have questions, you can email me or ask me on Monday. I will see you all Monday. Have a great rest of the weekend.